In this video, we are going to solve a problem on the reaction mechanism of metal complexes. The problem, they are given three complexes. We have to categorize them as inert or labile. The first one is aluminum with three oxalate ligands. Oxalate is bidentate ligand, so it is basically octahedral complex. Aluminum is in +3 oxidation state. Second one, vanadium H2O6 2+. Since water molecule is neutral ligand, vanadium is in +2 oxidation state. Last one, chromium with 3 oxalate ligands. Here chromium is in +3 oxidation state. First, let us try to understand what is labile nature. Let us consider a complex like this. How easily the ligand can be substituted with another ligand. That is mentioned as labile nature. If it is easily replaced, then the complex will be labile. If it is not easy, then this complex is referred as inert complex. Inert, the reactivity will be very less towards the ligand exchange. I have some doubt about the given options. I know very well that chromium 3+ forms inert complex. Aluminum and vanadium, aluminum 3+ and vanadium 2+, they will form moderately inert complex. Generally, we call them as labile complex, but in the given options, I can't find any option in which only Z is mentioned as inert. The first one, X and Y are inert, Z is labile. Z is not labile, it is inert. Second one, X and Z are labile. Z is not labile, so I can eliminate these two options. Third one, also they have mentioned Z are labile, so this is not possible. The last one, X is labile, Y and Z are inert. So Z is inert. What about Y? Y and X, they are moderately inert. They are not highly labile, same time they are not inert also. But based on this particular observation, I choose this as answer. Here I have a table from James Hughey. It is not possible to remember all the metals that will form labile complexes. Instead of that, we can focus on the metals that can form inert complex, because we have only a few metals. Only a few metals can form inert complexes. Here we can find chromium 3+, ruthenium 3+, platinum 2+, and ruthenium 2+. So these four metals generally form inert complex. The rate of exchange reaction will be very low. It will be at the order of 10⁻⁻⁶. These metals can form labile complex. So it is not possible to remember all these metals. Instead of that, we can remember chromium, ruthenium and platinum. So these three you can remember. Ruthenium in +2 as well as +3 oxidation state. So basically chromium, ruthenium and platinum. Three metals you can remember. Here you can find aluminum 3+ and vanadium 2+. I already mentioned they are not inert as well as they are not labile. They are in between. The rate of exchange will be at the order of 10⁻0 to 10⁻2. For chromium, it is at the order of 10⁻⁻⁶. So compared to this is nearly times more reactive. But in the given options, only the last one matches reasonably. So I have chosen the last option.